Hello, my dear students. I welcome you all in the lecture series of Database Management System. In past few lectures, we have learned how we can draw normal traditional year modeling diagrams. We can draw this traditional year modeling diagram using some basic steps that I have discussed with you. But after the complexity of the data increased, then in 1980s, normal traditional year modeling could not solve the real-life application problems. In that case, we had to introduce some more concepts, some new features into our traditional year diagram. And that particular year diagram will be called as extended year diagram or EER. So in EER, we will be incorporating some new features like generalization, specialization, aggregation. So we will learn all these new features one by one in this video. Also, we will see another kind of relationship which is called ternary relationship. So far we have seen binary relationship. That means the relationship only between two entities. But if more than two entities are involved, in complex cases, more than two entities can be involved. So in that case, how I can show the relationship? So in this video lecture, we are also going to learn a very important concept of ternary relationship. So let's not waste our time. So let's start. So let's start with the basic definition of extended year model. As I have already mentioned to you that when traditional year model could not solve the problem of data complexity, then we brought this extended year model where some enhancement were made so that it could handle the complex applications in a much better way. And that model will be called as extended year model or simply EER. Now in enhanced or extended year model, three new concepts were added. First one is the specialization, second one is the generalization, and third one is the aggregation. Now we will see all these new concepts one by one. First we will start with specialization. Now what is specialization? Specialization, it's a top-down approach where basically a high-level entity is specialized into two or more lower level entities. Now let's understand with some basic examples. Suppose I have got A and B. These two are entities. Now if A is specialization of B, then I can say definitely A is B because A is just a specialization of B. That means all characters of B is there within A. Only A is specialized to have some more characteristics, isn't it? That means A is B only, but with some specialized characters. And this particular relationship is shown by is A. Okay? And is A relationship is shown by a triangular structure. Now, since it is a top-down approach, specialization, that's why in the following example, in banking system, I have shown this same relationship is A in a top-down triangular manner. Understand? Now, in a banking system, the account entity, this can be specialized as savings account or current account. Means what? Means savings account and current account are nothing but accounts only, but with some specialized feature. Like account, this entity has got attributes account number and balance. Savings account has got also account number and balance, but current account has got account number and overdraft amount. Okay, that means now this is specialized kind of case. Then what is generalization? Generalization is just the reverse of specialization. Means it's a bottom-up approach. Bottom-up approach in which two or more entities, they are having a generalized form into a higher level entity. Because if they have some attributes in common, we can represent them as a generalized higher level entity. Now, it is nothing but a process of extracting common properties from the set of specialized entities, and we create a higher level generalized entities out of it. Let's take a very simple example. Student and faculty. They can be generalized. They are actually specialized kind of entity, and they can be generalized to form a higher level entity, which is person. So, person is a generalized entity. In this case, person has got person name and person address. They become part of the higher level entity person. And for student and faculty, they will also have name and address. But student will have another particular feature, which is student fee, and faculty may have another specialized feature, is faculty skill. So you have understood this generalization and specialization. They are basically shown by this kind of triangular structure, which is A kind of thing. Okay. In specialization, it is top-down approach. In generalization, it is shown by bottom-up triangle. And within the triangle, I have to write is A. Aggregation is nothing but the relationship between entity and the relationship. Means what? Means the relation between two entities is treated as a single entity, and aggregation relation is formed between that single entity and another entity. Let's take an example. Suppose center is an entity and course is an entity. So some coaching center is offering some course, right? Or some institute center is offering some course. Now, this center and course, this has got a relation offer. So now this offer will be treated in a rectangle. It is shown. This means that offer will be treated as another single entity, and then we can establish a relation calling enquire between that offered and visitor. Visitor is another entity, offer is that relation. So enquire is that kind of aggregation relation which is formed between an entity visitor and a relationship offer. Understood? Because whenever in real world, basically when a visitor or a student visits a center, coaching center, he or she will never inquire about the center only, right? Or just about the course. He will never inquire about only center or only course. Rather, he or she will ask or inquire about both the center and the course. Maybe he wants to know the result of the center, that particular coaching center. Also, he wants to know what kind of course that center is offering. That means there should be a relation between offer and visitor, and that is taken care of by this aggregation relation. Understood? Next comes the last kind of relationship, which is ternary relationship. What is a ternary relationship? Ternary relationship means when more than two entities are involved. So far what we have seen, binary relationship, where only two entities were involved. But in case of ternary relationship, basically we are showing relationship between three entities. So an entity in a ternary relationship is considered to be one if only one instance of it can be associated with one instance of each of the other two associated entities. Don't worry, I will give you a very good example. An entity in a ternary relationship is considered to be many when if more than one instance of it can be associated with one instance of each of the other two associated entities. Let's take an example. Then you will better understand this second point and third point. Suppose I have taken an example of manager entity, engineer entity, and project. Now, manager manages engineer, right? And also that manages is related to project. Now, how can I find out the cardinality of this kind of ternary relationship? Let's start. Suppose I have got manager, engineer, and project, and the relationship name is suppose managers. Now I will first explain what is one-to-many ternary relation. Now one engineer working under one manager can be working on many projects, right? So this one engineer working under one manager. So this N comes from it. Understood? Okay. Now, one project, again you take one instance, one project under the guidance of a manager can have many engineers. So this M comes, right? And one engineer means this engineer working in a single project must have a single manager. So this one comes. So you have understood how I can define one-to-many many ternary relationship. Understood? Now, let's take second example, which is many to many to many ternary relationship. How can I find out the cardinality of a ternary relationship? Just try to understand that part. Suppose we have got three entities, employee, skill, and project. Okay. And the relationship is called skill used. Means one employee, this entity, working on a single project can have many skills, obviously. So this M comes, right? One employee having a particular skill, he can use that skill in many projects. Understood? That means this N comes. Then lastly, one project requiring a particular skill, also it can be obtained from many employees. So this P comes. So this type of ternary relationship will be called as many to many to many ternary relationship. See, in real life problems, you will often get this kind of ternary relationship because their binary relationship will not be that much sufficient. Understood, my dear students? So in that case, you have to make use of this kind of ternary relationship concept. But I have taught you how you can find out the cardinality of a ternary relationship. Because so far we have seen 1:1, 1:many, or many to many. This kind of relationship between binary relationship means two entities were involved. But here I have shown you a ternary relationship where basically we are trying to find out the cardinality of that kind of ternary relationship as well. Okay, so I think you have enjoyed this lecture and definitely you have learned certain very interesting facts about database management system. So if you have liked this video, please give a like and please subscribe to my channel. So let's conclude over here. So I will see you soon in my next video. Thank you so much.